seen the introduction, then two types of lines we have seen. Okay, in these conversions we have seen two types of lines. So today we will start with another important one you have to learn is dimensioning. Right. The next important one you have to learn is dimensioning. So dimensioning in engineering drawing, okay, without dimensions it is meaningless. Okay, in a drawing without the geometry without dimension it is meaningless. Okay, so all the geometry should be specified with proper dimensions. Right. So that dimensioning, how we have to do it, we'll see. So what are the elements the dimensioning contains? We'll see. There are elements. Suppose I have a object visible edge. I have an object visible edge. Like this. So I want to dimension this. Say suppose this length of this entity, this object line is 100. So if it is 100, I have to dimension it. I have to show it in my drawing. Okay, how to dimension? What are the elements involved in dimensioning? So just to see, to dimension this entity, this line, I have to draw an extension line from the ends of the entity, okay, ends of the object, right? Object line. So this is the entity I have. So from its end, I have to draw an extension line. So the extension lines, draw the extension lines, you have to use your drafter. So always you use your drafter. So just you don't use your scale, right? So drafter it is fixed and it is used to draw parallel and perpendicular lines and inclined lines. Okay. So you'll see how to use the drafter. Okay. So using your drafter only, you have to draw your extension lines. Okay, suppose I am going to dimension this entity. So the extension line is drawn from the ends perpendicular to the entity. Okay, from the two ends of the entity which you are going to dimension, perpendicular to that you have to draw the extension line. So to draw a perpendicular line to this entity, so I have to keep my drafters one scale aligned to the entity which you are dimensioning. Now you can see the another scale is perpendicular. So using that I can draw an extension line. You see, I am leaving some gap and I am drawing an extension line. Okay. So this gap you should have a minimum of 2 mm. Okay. It should be 2 mm. Okay. A gap, because it should not touch the entity. Okay. Otherwise it will look like an entity. The extension line will look like an edge, object line. So you should leave a 2 mm gap. Then you have to draw an extension line. What is the pencil you have to use for extension line? 2H. It is a 2H line. A thin line, it is a 2H line. Similarly, you can move your drafter here. You can align to the object which I am dimensioning. So I can align and I can move it like this. I can remove that. I can draw an extension line. You see, this 2 line which is perpendicularly I have drawn to the entity at their ends. Okay, that is called extension line. This is named as extension line. So all your dimensions will have an extension line. Okay. Then there will be another element in dimensioning, that is called dimension line. So the dimension line will be parallel to the object which you are dimensioning. So this is the object I am dimensioning. So parallel to that, again you have to use your drafter only. So I will align my drafters one scale to the entity which I have to dimension. Then I can move then I can move parallelly. After, so I have to draw a parallel dimension line. Okay, I have to draw a parallel dimension line which will have a minimum of 10 mm gap. It will have a minimum of 10 mm gap from the object line. You see, it's a parallel line. I can draw it. So you see, this is a dimension line which will have a gap of 10 mm from the object line. It should have a minimum gap of 10 mm. Remember that? So each and every dimension line should have a minimum gap of 10 mm. So this gap is 10 mm. Otherwise it will be a wrong dimensioning. Right? So this is called dimension line. This is another entity in dimensioning. Then I have to show my arrowheads. So I have to show my arrowheads. Okay. Touching the extension line. It should touch the extension line, the arrowhead. It should not extend beyond the extension line. So which is my extension line? This is. So the arrowhead I will place on the dimension line. Okay, see here, I will place the arrowhead here pointing towards the extension line. The arrowhead I am drawing, it is pointing towards the dimension line. Is it clear? Right. So these are all the entities a dimension will contain. An extension line which is perpendicular to the entity object which you have to dimension. Then there is a dimension line which will be parallel to the entity, and it should have a gap of minimum gap of 10 mm. It can have more than 10 mm gap. Right. So then an arrowhead I have to draw it. That arrowhead you have to place it on the dimension line pointing towards the extension line. And it should not extend beyond the extension line. Is it clear? Now coming to the arrowhead. So the arrowhead, it's a very important one in your drawing. Right? So you have to neatly put your arrowheads. Otherwise you see in a drawing, you can see a minimum of 20-30 arrowheads. Okay. If you are not drawing properly, neatly, the arrowheads, then your overall drawing appearance will go. Right? So try to practice the arrowheads in a good manner to draw as clear as possible and as small as possible, but at the same time you have to maintain the ratio. So the arrowhead is having a ratio. I can see here the width of the height of the arrowhead. I can see if it is 1 unit, the length of the arrowhead should be 3 units. Right. Suppose you are in your drawing, you are drawing the height as in 1 mm you are using. The length of the arrowhead should be 3 mm. That is, this length should be 3 mm. Right. So try to draw the arrowhead as small as possible. Okay, 1:3 ratio. In a 1:3 ratio. Make a note. Quickly, parallel you can make a note. Right. So dimensioning, I will have an extension line, I will have a dimension line, then I will have an arrowhead. Right? So this, you try to practice to draw the neat arrowhead. It is very much essential to improve the quality of your drawing. Right? So and the arrowhead should be fully shaded. So in your class, I have different arrowheads, but you show a shaded arrowhead with 1:3 ratio. So 1:3 in the sense 1:3 units. Right. So you should not, I can see, I will show. You will be drawing the arrowheads like this, very big one, you will be shading. Like this, if I see in my drawing that the arrowheads, how will my drawing look like? Right. So the arrowheads neatly you try to present. It's very much essential. Right. In the practice session I will correct your arrowheads. You are doing, but now itself you try to draw a neat arrowhead, a small arrowhead. Right. At the same time you should have a ratio, 1:3 ratio. Normally you can have 1 mm to 1 1 mm or 1.5 mm approximately. We cannot measure it. Okay. So because we will be drawing, can have 1 mm or 2 mm. The length of the arrowhead I can have 5 mm. Okay, more 5 mm. Okay, approximately you can have the ratio. Right? Is it clear? Dimensioning for all of you. Okay, you should not make mistake in this. You see in the extension line, you should maintain a gap. Right? This is the elements involved in dimensioning: extension line, dimension line, and the arrow heads. We'll move on to, in dimensioning we have different types. Okay, types of dimensioning. You can see the two diagrams. I have two types: aligned system of dimensioning, method of dimensioning, and unidirectional method of dimensioning. Both are same diagram you can see. So what is the difference I have? Aligned system and unidirectional. Carefully you watch the dimensions and it's back to the dimension line. It is parallel to the dimension line. It is aligned parallel to the dimension line. Okay. And over the dimension line in aligned system. Okay, aligned method. In unidirectional you see, unidirectional, the dimensional values, how to show, it will be horizontal, always horizontal to your drawing. Okay. We will be writing the dimension values. It will be horizontal. You see here, it is here horizontal, the dimension value it is aligned. It is not horizontal. Okay. Whatever value you are writing, the dimension value it should be horizontal. So this horizontal system only we are going to follow. Right. Unidirectional method. Right. So here, how I can show the dimension? Here the 100 is line length. The dimension value you have to show it. Where I have to show it? Over the dimension line. Over the dimension line, exactly in the middle. Okay. In the middle, I can write 100 as per your lettering standards. 100, and this 100 should not touch your dimension line. It should have a little bit gap, and this 100 should not touch your dimension line. Right. So I have two methods: aligned system and unidirectional method. Aligned system, the values are aligned and it is over and to the dimension line. In unidirectional, it will be the values which you are writing in dimensions. Okay, it will be horizontal. Always it will be horizontal. You can insert either it is a vertical, horizontal, or inclined dimensions. Everything you will be inserting in the middle, and it will be horizontal. The values are horizontal. Right. So this is the types we have dimensioning one by one. So you have to follow these principles while you are dimensioning. Parallelly you write it, all the principles. This entity is 60. So I will give the entity value inside. This is 20. This entity is 20. This is 10. This is 40. And this angle giving it is 45 degree. This radius and giving it is 15. The overall length, okay, this one total entity is 85. Right. For this we have to dimension this. Okay. What you have to do? You neatly have to draw the diagram, okay, with the dimension exactly in your scale. Right. So this is for 60. How I can construct? This is 60. This is 20 horizontal line I can draw. Then 10. Then 20 horizontal line, vertical line 10. Then it is 40. Right. Then what I have to do? 45 degree line I have to draw it. Okay. 45 degree line. So what will be this length? The remaining length. Okay. Okay. This is 85. This is overall 20, 20, 40. This is 80. Okay, this is 85 plus 15, 100. So overall 100. This is the radius. So this length will be 100. Okay, overall it will be 100. So this is 40 means this length will be 20. So 20, 45 degree. Then this length is 60. So if this is 20 means this height also will be 20. Okay. 20, what will be the remaining this height?
40.
20, 60. In 60 you have to minus 20 minus 15. Okay, the remaining will be 25. Okay, 25 lines. So now you can be able to draw this diagram, okay, neatly with these dimensions. Now, how to dimension this? Okay, how to dimension this? Let's see. Once you have drawn this neatly in your okay. Now, as per the principles, how we can place the dimensions for this diagram, right? As per the principle, how we can place. You see, as usual, I can dimension this 85, right? Either I can dimension this 85, okay, this 60, as usual, I can dimension it, okay. This 20 I can dimension is 20, this 20 I can dimension is this 10 I have to dimension, 40 I have to show a dimension, then this 45 degree angular dimension I have to show, right? Then this 50 degree radius dimension I have to show it, right? So how I have to show these dimensions? Okay, as for the dimensions, how we have seen how to show the dimensions for an entity. Okay. So this 85, how I can show the dimension? I have to draw extension lines for this entity. See here, for this entity I have to draw an extension line. That extension line should be perpendicular to that entity, right? So it is just perpendicular. Using your drafter, you draw an extension line, and that extension line should not touch the object line. Okay, it should have a 2 mm gap. Then I can draw a dimension line. It will be parallel to the object line. So the dimension line I can draw it. It will be parallel to the object line. What is the gap? It is 10 mm. Right. Then similarly I can draw extension line for this entity 60 mm to dimension. I have to draw an extension line perpendicular to that entity. I should maintain a gap of 2 mm. Perpendicular to that entity I have to draw extension line. Similarly, this 20 mm I have to draw an extension line. Right. Now, for this extension line, the dimension line, it should be parallel to the object line. Similarly, it should be so the gap should be maintained. Okay. So I have 3 dimensions. Okay. You should not separately, you should not dimension. Okay. In a different location. The dimension line I can draw all together as a single one with the same 10 mm gap. So even though I am dimensioning this 20, the 10 mm gap will come here. I told the dimension line should have a minimum of 10 mm. It can have more than 10 mm. If I have in this region, it will be neat. Okay. So I have shown the dimension of this 20 aligned to this or other dimensions. Right. So again it should have the 10 mm gap. Right. We will come to this angular and radius dimensions later. So you have to neatly show your arrowheads. Small arrowhead with the ratio show the dimension values in this. Okay, as an unidirectional procedure. Okay, as a unidirectional procedure, I can show the dimensional value. The dimensional value, what I am going to follow here, you see here. Yeah, you make a note. Below that you make a note. Okay. You make a note. Follow unidirectional procedure. Follow unidirectional procedure. In your dimensioning, you have to follow this. Follow unidirectional procedure. The second one. Place the dimensional value above the dimension line. Place the dimensional value above the dimension line for horizontal dimensions. For horizontal dimensions only. Okay, what? Place the dimension value above the dimension line for horizontal dimensioning. Okay. Third one for above the dimension line. Right. Insert the dimension value. Third note, insert the dimension values in the middle of the dimension line. Insert the dimension value in the middle of the dimension line for all other dimensions. For all other dimensions.
Insert the dimension
value in the middle of the dimension line for all other dimensions. So we are combining these both. Okay, for horizontal dimension alone, I am going to place my dimension value above the dimension line. For vertical and inclined dimensions, whatever I am going to have, I have to insert it horizontally in the middle. So here, for this is a horizontal dimension. Top also it is a horizontal dimension. This 10. 40. I have shown this dimension. No, this is the end. I have given a rough. I have given the values that you have to show it. Neatly you have to show it. Right. Dimensioning it. You see here, the values I have given, I am going to dimension it. Okay, in a proper manner. Okay, in a standard manner, I have to show the dimensions. Since this is 85, I can show the 85 in the middle. Show the 85. It is placed above the dimension line in the middle. Why? It is a horizontal. As per my note, it is a horizontal dimension. So I have placed above the dimension line. So what else horizontal dimension we have? This is a horizontal dimension. This is the other one. So I can place the dimension values above the dimension line. 20 in the middle. This is 20. This is 40. So now I can place this. So it is unidirectional. See, this is a vertical dimension here. Insert it. Yeah, I have to insert it in the middle. So this is 60. So after some point of time, you need not erase it. Okay. So you know this is a vertical dimension. You are going to dimension. Okay, you can leave space while drawing the dimension line in the middle. Right. Carefully you do it. Right. Now I have erased in the middle.
What about that?
Right. I will show. Now this is a 45-degree inclined line. This is an angular dimension I have to show. Now you see here I have a dimension, entity, that is what is its height, 10 mm. Okay, 10 mm where I have to show it. I have to show it anyhow. I have to show in my drawing. So this 10 mm, if I extend an extension line like this, what will happen? I have to show this 10 mm outside. Is it right? You see the principles. One principle is saying the extension line, about the extension line. Extension line should not cross the dimension line. So this is wrong. So another principle it show the smaller dimensions first. Okay. The next dimensions, okay, consecutive dimensions, larger dimensions should be placed after that. The very small dimension has come first, the other dimension should come after that, right? So what I have to do before that, this 10, while placing, I have to show the 10 mm first of all. You see here, this 60 is wrong, so I have to extend this extension line. Right, extension line. So instead of this here, if I showing this two arrowheads here, I don't have a space to place my value 10 mm. So what can I do? You see another principle is that I can place my arrowheads outside if I have a smaller space. So what I can do, this arrowheads, instead of showing inside, so I can have a dimension line like this. I can show the arrowheads outside pointing towards the extension line, touching the extension line. Right, now this value will be 10 mm. Since it is a vertical dimension, I have to insert it. Right, since it is a vertical dimension, I have to insert it. Is it clear? Now I can show my 60 mm after this 10 mm. So what should be the gap for the 60 mm line? 10 mm gap from the previous dimension. So that also is given. For each and every dimension, you have to maintain that 10 mm gap. Right. So I have to maintain another 10 mm gap. Then I can show my dimensions here. So this is 60. So I can see, I can dimension this in another manner. Anybody? So this portion I can use it instead of showing a separate 60 mm. The overall is 60. This is 10. So I can show this portion as 50. So I can place an arrowhead here. In this dimension line, if you place an arrowhead, I can show a value of 50. In a single dimension line, I can show 50 and 10. So altogether, it conveys the same meaning. Right? Is it clear? So I need not dimension this separately the 60. Okay, I can place a 50 mm dimension here. So that 50 mm dimension, for that 50 mm dimension I will have two arrowheads. The same arrowhead will be used for the other dimensions also. Right. So that is also allowed. Is it clear what I am telling? Right. Now this is way you have to dimension a horizontal dimension and a vertical dimension, and the dimension value for an inclined horizontal dimension you have to place above the dimension line. For vertical dimension you have to insert it, and similarly inclined dimension you have to insert it. Right. Now coming to the angular dimensions. Okay, the angular dimension, this is 45 degree. So how I can dimension this? One thing I can do it, I can dimension, I can extend it like this. I can extend this, I can show outside. The first thing the first principle what it is? No, first principle you have to show all your dimensions outside the drawing, outside the object. Okay, so you should not show the dimension inside the object if possible. Right. Mostly you have to try to show the dimensions outside the drawing, view, right, outside the view. Now here if I show the dimension outside the view, the extension line will be crossing. Okay, so I can avoid this confusion. What I can do, I can show the 45 degree inside the drawing. So I can draw an extension line like this for the angular dimension. Right, the angle, to show the angular dimension, I have to draw an arc. Conveniently, I have to draw an arc using your compass. Right. You should not use your free hand. So use your compass. Place the compass exactly at the center. Okay, where the dimension starts. So where the extension line starts. Okay, this is the location. I have to fix my compass, and I can conveniently draw an arc. Okay, neatly you can draw an arc using this as center. Okay. drawn out like this, I can show the dimension. You see, what is the value? It is 45 degree. 45 degree I have to show it in the middle, and it should be horizontal. The value should be placed horizontally. So it is 45 degree. 45 degree. Right. So this is how you have to show your angular dimensions. So if possible, you represent the angular dimension outside. Okay, you have a space. Okay, you don't have any disturbance. You show neatly on outside the view. Right. Then coming to an radius dimension, coming to the dimensioning an arc or circle. Okay, here I have an arc. How to dimension the arc? See here, to dimension any arc or circle, what you have to do? You have to draw an extension line from the center of the arc or from the center of the circle. Remember that. You have to draw an extension line from the center of the arc or from the center of the circle. So what is the center of the arc here? The center of the arc is somewhere here. You have to show the center of the arc. Right. Then from the center of the arc, draw an extension line towards the arc. Okay, this is my line. So this extension line, what I am showing here, it is named as leader line. Okay, it is named as leader line. Okay, this line, then I have to finish it with a horizontal line. You see, I have to finish it with a horizontal line. I have to draw an extension line which is nothing but a leader line that is towards the arc which you are dimensioning, and it should start from the center. Remember that. Then I can place my arrowhead either inside or outside pointing towards the arc. Right. So here I am showing the arrowhead like this. I am showing the arrowhead like this. Okay, pointing towards the arc. Now what is the value I have to represent here? It is 15. What 15? Is it diameter 15 or radius 15? Radius 15. So to show the radius 15, I have to use a symbol R. R 15. To show the diameter value, I have to use the symbol diametrical symbol. Right. To show the radius value, I have to use the symbol R. Right. So now this is radius 15. See, R 15. Clear? So for angular dimensions, so for circular dimensions, okay, or any arc, the dimension line which is it should be extended from the extension line. It should be extended from the center. Remember that, right? It should be extended from the center, and we can show an arrowhead pointing towards the arc or circle. Okay. So for arc, we have to show the dimensions only in radius. So you keep it in mind. Okay, for arcs, any dimensions value you are showing, it should be in radius. Suppose wrongly you should not show diameter 30. I can show you. It will be a diameter 30. Okay. For arc, it cannot be diameter 30. Okay. You should not represent with a diametrical value. Right. Suppose you have a circle. See, suppose you have a circle like this. Suppose I have a circle. So how I can dimension this circle? How I can dimension this circle? Starting from the center to any convenient angle, wherever you have space. Okay. It doesn't matter. Wherever you have space in any convenient angle from the center, I can draw a leader line, then I have to draw a horizontal line. Okay, then I can place an arrowhead. Now what is the value I can represent? Here in the circle, either I can represent radius value or diametrical value. Okay, since it is a circle, it is more prompt to specify a diametrical value. Right? What is the diametrical value? You can specify dia, say 30. Right? Right? For diameter, better you can show, you can extend, you can show it with two arrowheads. Okay, so this is here, one arrowhead is here, another arrowhead is here. I can show it with the two arrowheads. You can show it with a single arrowhead, but the value, dimension value should be in diameter, with the diameter symbol with the diametrical value. Right? You have to show the radius value only for arc. Okay, for arc you should not represent the diametrical value. Remember that. Right? So similarly, these two arrowheads I can place inside also. And this angle doesn't matter. Okay, the leader line angle doesn't matter. Wherever I have space, along that direction I can extend my leader line. Then I have to draw a horizontal line over that I have to place a dimension value. Make a note. So is it clear here? Do you have any clarification in dimensioning?
So this one is leader lines. Which one is the leader line?
This is nothing but leader line. So for a circle or arc, whatever line we are extending from the center, that is named as leader line, a separate name. Right?
How to draw arc? How to draw the arc?
Which arc?
Sir, the arc is 15 mm long, sir. So, how to draw it on the object?
Compass. Measure 15 mm in your compass. You mark the center here. This is no 85, you know. From here, this distance, what is the distance? It is 50. It is going to be 50. So, you see, it is nothing but a circle of radius 50.
So, as per our convenience, we can choose any center and
exact center, not any center. This is 85. Right. So from this location, I can go through the center. What will be the distance? 50. From there, I can draw an arc. Is it clear? Okay. You have to draw, show it in your notebook. Okay, neatly it should be drawn as per the dimensions, and neatly it should be dimensioned with a proper neat arrowhead. I need the next class. Right. Dimensioning, do you have any class? Right. We'll move on. You see the next figure. You see, you tell me what is the mistakes in this dimension. I have some mistakes.
10 is written on
10 is written over. It should not be. Right. What else? You see, one by one. 60 and 50, you see, the gap is very less.
Yes.
It should be 10 mm.
Yes.
Right. Then 30 is inside. You should not. 30 you should take outside. Right. 10 also you should take outside. Right. 60 should one by one. 30, this is the another one. Very good. It should be unidirectional.
Sir, 60 that 50 and 60. Yeah, above the line.
above the line.
Horizontal here.
Above the line. Here 20. Here 20 you have written above the line.
That gap is wrong. What is the gap?
Both 50 and 60.
Just 50 for our okay. What I have given the note, it should be above the line. Right. As per what you are going to, how you are going to show, as per that 3 notes. Okay. You have to place the dimension value above the line.
So horizontal.
Yeah. Horizontally. Right. And this dimension you have to show it outside. So one more thing in that principle you should not dimension the hidden lights. Right. You see the another drawing. Just show whatever mistakes we have.
Sir, the arc is sorry, estimate the diameter for the arc.
The arc is in, as I told, the arc is shown in diameter. It should be in radius. That is the wrong one. Then.
So that arc one place should be written on that line.
Yes, sir. Okay. Over. Okay. So that is diameter. So right. It should come from the center.
Sir, below sir,
I should show show the center. I should show the center. From the center I should get it. Okay, then.
Sir, it should be written on the
Yeah, on the horizontal line. So this is one procedure I can show you. No mistake. Then, you see this 17
should be above.
No, what is wrong in this 17? Above it, okay, that is above, all the dimension value should be above the dimension line as well as no, you see the 17 is dimension for the hidden lines, hidden details. I should not dimension the hidden details. Right. So I can have another view for this same geometry. I will have a same object. I will have another view. There, that holes will be visible one. There I can show the dimensions. Okay. For this view, I have a hidden detail. So at the hidden detail, you should not dimension it. So this is a hidden hole. This is a hidden hole. That hidden hole center line, I should not dimension it. I should not show it. Right. So this is the mistake. These mistakes you should avoid. Okay, in your dimensioning. Right. Is it clear now? So we will move on to the next one, geometric constructions. Again I repeat, show your arrowheads neatly, practice it. Okay. In geometric and some simple geometric constructions we will do, and what is the most extensively we will be using in your semester, in your drawing, that geometric constructions we will see. Right. You just start with bisecting a straight line. So suppose I have a line. Okay, I have a line with some length. I want to bisect it equally. How I can do it?
So we can take the distance.
Diameter.
Yeah. I have a line. How I can bisect this? Measure from this end. I can measure. Okay, I can measure more than a half distance. Okay, okay, right. I think all of you know this, right? So I can measure more than half distance in my compass. I can cut an arc above the line, below the line. The same distance I can keep it from the other end. I can get an arc like this, right? Hence I can join these two lines. Okay, that joining line will bisect the original line. Okay, the joining line you should not show it all the way. Okay, you can keep your drafters joining these two intersections. Okay, just where it is intersecting, just you can get that location, right, from the original line. Is it clear? Now similarly, the next one, how I can bisect a given angle. Suppose I have an angle, angular value like this. How I can bisect this? Same principle. Okay, I will finish up. You take any arbitrary distance in your compass, right? I can have it from this location. I can draw an arc. So this is an arbitrary distance. I am drawing an arc, right? So now I have this arc which I have drawn. It intersects the original angular lines at these two locations. From these two locations, okay, I can take more than half of this arc length. You can take more than half of the arc length. That is an arbitrary one. You can take more than half of the arc length with compass. From here I can draw an arc. The same thing, I need not cut it here. Okay, from the other end, with the same measurement, I can draw an arc here. It will intersect. Now by joining this to the center, it will divide the angle equally. What angle you have, it will divide it equally. Right? Is it clear? Now similarly, for any equal number of divisions in a given angle, I can use the same procedure. Suppose I want to divide this again by 2 means, I can use these two or okay. Occasionally I can have another intersection. I can divide this by equally by 2. Similarly, this division I can make it another 2 halves, equal halves. So I can use the same procedure. I can have another divisions. Okay, for equal divisions, this is the procedure. Right? I think this you are aware of. Okay, well aware of this. Bisecting a line, bisecting a given angle. You will see this one. dividing a line into any number of equal parts. Right. So this we will be using in your subject. Okay, frequently we will be using this. You take a small exercise, divide a line of length 90 mm, divide a line of length 90 mm. So divide a line of length 70 mm, divide a line of length 70 mm into 9 equal parts. Divide a line of length 70 mm into 9 equal parts. So I have 70 mm. How I can divide it equally into 9 parts? See, I have a 70 mm line. So that line is 70 mm. Right. I have to divide it into 9 equal parts. If I divide 70 divided by 9, I will get some value. Okay. So using my, if it is a perfect number, I can divide it using my scale itself directly. Okay. Now the 70 by dividing into equally 9 equal parts. Okay. I have to go for a constructional procedure. Okay. What is the construction procedure? Listen carefully. So what I can do, I can take any arbitrary angle. Listen, this is my original line. This I want to divide it into 9 equal parts. See what I can do. I can take any arbitrary angle. It is a construction procedure. See, I can take any arbitrary angle. I can draw a slant line. Okay. Along this slant line, I can have a arbitrary measurement in my compass. Okay. Arbitrary measurement, say 10 mm. Okay, in my compass. That is arbitrary. No need of 10 mm. It can be 15 mm. Right. 10 mm I can have. The construction inclined line what I have drawn. Okay. In that 10 mm I can cut 9 divisions. The same 10 mm I can cut 9 equal divisions. See, is it clear? The construction line, the inclined line, it is for one arbitrary angle. Right. The length which I have taken, it is an arbitrary length. So that same length I can cut 9 divisions in the inclined line. Okay. Now, how I have to bisect this? What I can do is, the last division, I can join it to the other end of the original line. So the last division, I can keep my drafter, I can connect the last division to the other end of my original line. Now from here, what I can do, I can fix my drafter to this line. My drafter will give me parallel lines, okay, to any line. To any line, I can fix my drafter, I can draw parallel line to that line. So using my drafter, I can fix my drafter here. I can move on my drafter to the next location. So it will be parallel to this line. So now it will divide my original line like this. I can draw a parallel line to this. It will divide my original line. Similarly, I can move on my drafter. It will divide. Divide the original lines like this. Now these locations are the divisions, 9 equal divisions I have in my original line. So what you can do, the extreme line you can join it, connect it with a 2H line. Okay, the white lines are 2H, these are all construction, it should not be visible in your drawing sheet, right? It should be very light. So the extreme line I can connect it with my drafter and fix your drafter to that. To move your drafter just parallel to this location, wherever it intersects, that location alone we mark it. I can avoid these constructions. Okay, that location alone we mark. Our intention is just I have to divide my line into 9 equal parts. Right, these are all the construction work. Okay, that should be very light. Okay. So whatever portion you are able to try to avoid, you can avoid it. Okay, in your construction work. Now, just you see, in your drafter, how I can listen in my drafter, how I can dividing a line into any equal number of parts. So we have some other geometry constructions. We'll continue that in the later lecture. See, here what I am doing, the drafter is there. See, the title block should be like this. Okay, when you are bringing your drawing sheet, the title block should be, you see the parallel lines are not visible. So only the letter should be printed neatly. What I am doing there, you have to fix your drafter to your reference line. That is what is nothing but your layout line. The layout line, what you have, that is going to be your reference. Okay, from that reference I am bringing my drafter. So I am fixing my drafter to that reference line. Then I am bringing my drafter to see. I am drawing a horizontal line like this with a H pencil. Okay, that is an object line, actually the original line. Okay, I am drawing to the length. Then you see this is the original line. Then I am changing my pencil to 2H. Okay, this is all since I am going for a construction, right? So you have to shift your pencil to 2H. Then you see I can conveniently tilt my angle to any angle. Okay, there is an arbitrary angle. So to that angle I can draw, to any angle I can draw an arbitrary line, inclined line. So it can be any angle. So it is not a perfect angle in your drafter. In the drafter you see this is a marking. Okay, there is a marking for a protractor, right? I will explain the drafters in detail in the next lecture, right? So I have drawn an inclined line. You see that inclined line is very light. It is not visible. Okay, so that inclined line, along that inclined line, you have to use any arbitrary length. Any arbitrary length in your compass you can take. You can cut the 9 divisions in the inclined line. You can cut 9 divisions in the inclined line. Some mistake in that. Okay. Now I am the same 2H pencil, using the 2H pencil, I am connecting the last division with the other end. I am connecting the last division with the other end. Okay. With a 2H line. Right. Right. I am tightening the knob of the drafter. Now wherever I move my drafter, I will get a parallel line to that line. Okay. Wherever I move it along using that scale, if I draw, I will get a parallel line. So I am moving to the next division. Where it intersects the original line, there just I am getting the divisions. Okay, all the way I am not drawing the line, construction line. Right. Then you can show the division numbers. Is it clear? This is how you have to divide a line in any equal number of parts, any required number of parts. The video is taken by us only, it is not that much clear. Okay, perfect. What I am doing here, I am writing the division value, right? Here. I have 9 divisions.